I want to do a demo with EscapeSpeed. EscapeSpeed deals with the topic of gravity, a concept that's very important really for all areas of science, but especially for astronomy. Because as I've said before, the story of astronomy is frequently the story of gravity and of light. And gravity is the thing that often makes things move in how we observe the universe. There are different ways to describe the strength of gravity. Gravity of the Earth is what holds us down on the surface of the Earth. As we all know, we've been able to launch rockets into space. We've sent probes to other planets in the solar system. We've sent people to the moon. So what does it take to do that? So one way to characterize how powerful gravity is for an object and its ability to hold on to things, or to hold on to like an atmosphere, say for a star, how capable is it of holding itself together is this idea of the escape speed. So let me just do a common example. What I have here is a small ball, and I can toss the ball up, down it falls, and I catch it. You've heard the phrase, what goes up must come down. It's not entirely true. If I throw the ball harder, it goes up higher. What does harder mean? Harder means that if I put more toss into the throw, so that when the ball leaves my hand, it leaves at a faster speed, then it can go further before it slows down, turns back around, and falls, and I catch it. In fact, if I throw it as hard as I can without hitting the ceiling, those actually go off camera and then come back on. It takes longer for it to fall back. Turns out when you throw something, the silly object is trying to do an actual orbit around the Earth. Of course, the ground would get in the way, so it can't go around the center. But that's actually what it's trying to do. It's trying to go in an orbit. Okay? So obeying Kepler's laws for orbital motion. Escape speed then, how hard must I toss it? How fast must the ball leave my hand so that basically it goes up so far that it never actually turns around and falls back? One way to say it is it takes infinite time for it to turn around and fall back, or it goes an infinite distance before it attempts to try that, or whatever. That doesn't mean that gravity isn't affecting its motion. The gravity doesn't turn off when something is fast moving at the escape speed. All it means is that if you can get something to go at the escape speed, then it's never going to come back. And so that's one way to illustrate the idea of how strong gravity is. In the case of the Earth, the escape speed is about 11 kilometers per second. So that's how fast something has to move in order to go into space and then not fall back. Never mind the atmosphere of the Earth. For Jupiter, which is a larger object, but also a more massive object, it's about 60 kilometers per second. In the case of the Sun, 600 kilometers per second. Things have to go really fast to escape from the Sun.